Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilham Hadi bin Halim. In this wonderful day, I would like to present my research project which titled Temperature Control of Distillation Column in Natural Gas Processing. First of all, I would like to introduce to you about my research. As mentioned before, my research title is Temperature Control of Distillation Column in Natural Gas Processing. The distillation column that have been focused in this research is depropanizer, which has been used to separate propane from natural gas. The temperature in the column need to be controlled in order to achieve desired output precisely. However, there will be problem to design control system for this column due to its behavior as nonlinear process. But this research has proposed an efficient method to control the process, which is by using neural network control model. Basically, neural network is a computing model which composes a large number of layered structures. Seems like the network structure of neurons in the brain with the layer of connected nodes. In that case, neural network is the most suitable to be implemented in modeling nonlinear process like distillation column. Okay, the objective of this research is to develop nonlinear neural network model that relates input and output of distillation column in natural gas processing, which is the propanizer, and to design neural network control for distillation column. The problem that lead to the research is the conventional PID controller is not effective enough to control the temperature of distillation column if sudden disturbance or set point change occur. This is because PID controller will struggle with long settling time and exhibit high overshoots in order to achieve the desired output. This will affect the conversion rate of the process and also will affect the purity of desired product. Okay, the scope for this research is based on process control that control temperature parameters in the propanizer. The neural network control model has been used in this research. This model was designed and simulated using MATLAB software. Okay, as you can see, this is the neural network structure model for this research. There are two inputs and one output. The input one is return rate and the input 2 is bottom temperature, while the output, which is the desired target variable, is top 3 temperature of the column. Okay, as you can see from the figure, there are blue circles that represent the nodes. These nodes are connected by a layered structure of neurons, which is the line. This figure also have been divided into 3 sections. The first section is input layer, next section is hidden layer, and the last section is output layer. For the hidden layer, the number of hidden neurons can be chosen while during develop the neural network model. This can be chosen by using the neural network time series tool in the MATLAB software. Okay, next, for the methodology, the research start with study and analyze the process of the propanizer. Next, find the relationship between variables by sensitivity analysis. This is done by comparing the effects of several variables with the target output, which is top 3 temperature. This method is using Microsoft Excel to compare the sensitivity of the variable towards the target output. Okay, after that, from sensitivity analysis, the input and output of neural network will be determined. As mentioned before, there are 2 input and 1 output. The input are reflow return rate, and bottom temperature, while the output is top 3 temperature. Then, determination of mathematical model of the process by using system identification tool in MATLAB software. This is to find the correlation between the input and the output of the process for simulation purpose. Then, the neural network will be developed by using input and output that have been selected in the previous method. The model will develop by using neural network time series tool in the MATLAB software. After that, the control scheme have been designed by using Simulink also in the MATLAB software to evaluate the effectiveness of the controller. This evaluation will prove that which controller is more effective in handling this nonlinear process. Okay, for the result, the first figure shows the scheme for comparison of neural network controller. This comparison is varied by different number of hidden neurons. The hidden neurons were varied from 2, 4, 6, 8, 10, and 20 hidden neurons. This comparison is focused on the response of the controller towards set point change. Okay, the figure below shows the result for this comparison. From this figure, the neural network controller shows good result in tracking the new set point. But the model with 2 hidden neurons did not able to track the new set point. This result may cause from some errors during the development of neural network model. Okay, next, the figure shows the controller effectiveness comparison between neural network controller and PID controller. This comparison was done by evaluating the response of both controllers towards several set point changes of the same process. This evaluation is based on the percentage overshoot and the settle time of the response. Okay, as you can see in the last figure, it shows that the neural network controller is more effective than PID controller. This is because the PID controller exhibit high overshoot, while neural network controller has no overshoot or oscillation at all. Okay, for the settling time, neural network controller seems like to achieve the new set point faster than PID controller. So you can see that neural network controller is more effective than PID controller. Okay, to be concluded from the experimental result, the neural network control model shows stable interaction with the process and great performance in handling the nonlinear process in order to achieve desired output. Neural network control model has proved that it has a great potential in replacing the conventional control system, especially for nonlinear process in the future. For recommendation, the neural network model must be developed properly, including accurate data preparation in order to get the best performance of the controller. This is because the neural network model needs to learn and train the process before predicting the target output for the process. Okay, that's all from my presentation today. Thank you for listening and Assalamualaikum.